This conference will now be recorded. This conference will now be recorded.
Okay, so we'll not go in very depth. I would like to put it very simple. I just wanted to make you understand in a better way how garbage collection can help for a better improvements for any kind of simple to Java, simple to complex based Java applications. So before we go ahead with Java garbage collection, we already spoke about different memory areas that we have inside JVM. So we already spoke about the JVM memory model. We already spoke about the automatic memory management, like heap, non-heap areas, PermGen, Metaspace. So now today we'll talk about mainly where the objects are stored, what are the steps in GC, what are all the different GC types, why you have to use them, and we have already explained yesterday the difference between PermGen and Metaspace. And for this GC activity, heap dump analysis, so heap memory related issues, everything you have to monitor JVM, right? If you want to look at the GC past time, if you want to look at which objects are taking high amount of memory or high amount of CPU or high amount of time, you have to monitor the complete JVM. When you monitor the JVM, then only you will be able to understand what exactly happened with all the heap related areas, what are the metrics you need to monitor from heap, and you need to continuously monitor something called minor GC, major GC, and full GC. Got it? So there will be some different bottlenecks every time from different areas of heap, and you or a Java developer will not have a complete control on a Java program to stop the GC or to forcefully make GC to happen. You will not have that control, complete control over it. But however, the developer, the Java developer who has developed the application, who has written the code for that particular piece of functionality, he can make that object to be eligible for GC, right? Before we start with garbage collector, we already discussed the different memory areas that we have in Java memory model, the young generation, old generation, and metaspace, which is also called the perm generation, right? So basically, when we talk about heap or any GC related issues, the first error that we get is the out of memory exception, as explained yesterday, and it is directly indicating that your Java application ran out of memory. And see, before that, I am going to share this PPTs. This is a Broadcom PPT. Don't share it with anyone. So there are plenty of concepts that are explained here as part of garbage collection. We are covering all of them, but don't go with the definitions or different things that we have across different blogs, Java Revisited, or how to do in Java, or gigs for interview. So many uh, websites are there, so you can go through all of them, but I want to make this concept simple. Uh, have some basic understanding to moderate level understanding how garbage collection will work and which garbage collection algorithm that I have to choose, and what is the performance impact that I get frequently when I use any of the Java application. That is what you should mainly understand from a performance standpoint of view, right? So always the error that we have is Java heap depletion. Example, it is not the operating system or native memory. The JVM has its own memory, okay, own memory capacity settings. And this Java garbage collection is the process of Java programs that perform automatic memory management. If you remember, I have already told you in the earlier languages like C, if they want to create an object, they have to create it manually. And if they want to delete that object, even their manual intervention is required to destroy that. Whereas in Java, we don't have that option. There is a process called garbage collector, which automatically takes care of the automatic memory management. When the objects are created, it deletes all the useless trash. This is a basic definition. When I call it useless trash, when an object is used or when a particular task is completed, the garbage collector will automatically identify that particular object has been marked as completed. It completed its job, and it will automatically delete that particular object, and it reclaims the memory. Means that it frees the memory, and it will make the memory available for the next objects that are being created in pipeline. Okay, so every time, majority of the symptoms are you will have a sudden failure, or you see a very major slowness in any of the Java application. Only thing that you need to do is you need to monitor JVM with all these metrics. What is happening to minor GC, what is happening to major GC, whether yesterday someone explained me, right? There is something called sawtooth pattern. You need to check the heap allocations on all the different areas. You need to check something called stop the world events, which is also known as GC pause time. It should be it should be in the very acceptable limit. I'll explain you what is stop the world events. And most importantly, you see a message, you see an error, or you find some abnormality with CPU utilization. You will see the sudden spike in CPU utilization on the server due to increased GC activity. Got it? So I'll tell you what is this, how the GC activity will increase. I also told you this point, when the JVM is getting close to run out of memory, if it is full of objects, and there are referenced objects, there are unreferenced objects, and some of the objects are not being deleted with GC. Even GC is not able to delete any of the objects which are not being referenced, or which are completely dead. So at times, those dead objects which are not referenced, what they will do is it will continuously occupy the memory, and it will create something called memory leak. You need to handle a situation out of memory and a memory leak, and also you need to understand what exactly is creating this high spinning of CPU utilization, especially with high GC activity. And there are different GCs, and most of the possible causes for all these cases, I mean different errors that you see in uh, Java based applications. For what reasons you need to take heap dump, for what reasons you need to understand garbage collection. So that is only because of all the inadequate Java heap capacity settings, only for the reason XMS and XMX values. Yesterday, if you remember, I told you that you can also go with the default heap values, but only if you are using Java 8 and above Java 8 versions. The reason is because the heap set, there is an option of there is a unique feature from Metaspace from Java JDK from Java 8 versions, which will automatically increase the memory in the heap itself. Okay, so from Metaspace Java 8, you can, based on depending upon your requirements or the inputs that you get from your application teams, you can go ahead and test with default settings of heap. But before, below Java 8 and all, it is not recommended. You need to understand what can be your minimum and maximum heap size. Okay, so and we already spoke about yeah, this is another one important point, excessive application memory footprint. So if the application memory footprint is too high, even if you do multiple rounds of testing, okay, to optimize the performance of your Java application, but still it is not improved to 0.01 second, it means that you have a lot of inefficiencies of code. The code is not appropriate. There is some lot of redundancy. It can be because of some lot of duplication of data, some reusing of the code. And the application footprint, if it is too high, it will try to work too much on a single process, and in this case you will have high CPU utilization, high memory utilization, high GC activity. For that reason, you need to talk with all the respective teams to understand what kind of footprint you can have on your Java based application. Okay, footprint again, it cannot be decided from the performance engineering team or a performance testing team, or the Java developers. It is again the infrastructure team or the architects team who will decide what can be the footprint of this particular JVM. Accordingly, they write some code, they can deploy something on it for a better performance. And every time, if you have some kind of optimization from the coding side, some coding level techniques or code optimization best practices, if it is a part of your every project, then you will see some kind of improvement, performance improvement from release to release. Even if you call it in the name of hotfix or some kind of new patch or a new release, new build, anything, you need to have an efficient memory footprint. You need to understand the different code optimization techniques, and from the coding side, it has to get optimized with so many other rounds of code review process. Then only you will see some kind of improvements in the performance. Like for example, 11 seconds of response time cannot be optimized directly to 5 seconds of response time with when you test with 500 concurrent users. So to bring that from 11 seconds to 5 seconds, or 3.5 to 5 seconds as an industry standard, it is your job to investigate in multiple directions, especially with heap. Only especially when you talk about JVM completely talks about heap dump analysis, the thread dump analysis, and GC tuning. And most importantly, it is required it is required to understand all the different garbage collection algorithms that you can use. Because if you take any of the application, right, if you want to baseline and benchmark, so there was a scenario in my organization. You have to test your application using all the different algorithms that you have. It is serial, it is parallel, it is CMS, concurrent mark and sweep, it is G1C, garbage first, and you have to select different garbage collection algorithm, and you have to performance test for 2 hours with 250 users and 500 users in both QA environment and prod environment. This is one kind of baselining and benchmarking to understand how each GC algorithm is working with respect to performance. Got it? So you need to get that understanding on the various GC algorithms, and which one I have to choose is the most important question. Which GC algorithms do I need to choose, and when I have to use them? Okay. And you have various diagnostic tools to monitor all of these activities. Heap, different areas of heap, the GC activities, minor, major, full GC, along with the GC pause time, which is also called stop the world events. So few of the common solutions for all of them are you can use JVM Verbose to analyze GC logs. You can use Java Visual VM, JConsole, JProfiler, YourKit Profiler, and yesterday I have shared you App Perfect Java Profiler that is not getting installed because of some issue. So these are all the various tools to analyze all of them, to take multiple heap shots, thread snapshots, and to analyze GC logs. And apart from this, you also have various online analyzers like heaphero.com. There are a few other online uh, analyzers. Like if you take a snapshot, if you save your .hprof file, which is a heap dump, you can directly upload in the online website like heaphero.com, fastthreadio.com for thread dump analysis. If you go there, if you browse, if you upload that file, and if you click on analyze, it will read the file, it will analyze the file, and based on some intelligence feature it has, inbuilt feature, so it will tell you what are all the primary suspects and secondary suspects. That is what it can do for you. But again, it is the performance engineer and the developer who has to understand what happened. Okay, and you need to look at few metrics, what increased with what, and accordingly you need to come to a conclusion, and you need to write a recommendation or a suggestion after that issue is fixed. You need to write that in the report. This is how the performance has been improved. Okay, for that, for all of them, you need to increase the heap. For all the common solutions are, you need to increase the heap, and you need to continuously monitor. And profiling is more important to resolve all these memory leaks, out of memory errors. You need to have a thorough profiling knowledge, especially from the Java side. It is always good if you have some good hands-on Java experience, not Java. Core Java experience would be more than sufficient for any performance engineer. So for that reason, I would suggest everyone to learn core Java if you want to understand all the various methods or object profiling techniques, different type of objects. Or if you want to, there are few techniques that can be used, basically they are used by a Java developer. If a performance engineer wants to troubleshoot, then and there, if he is knowing this core Java, he can do that activity from his end, so that he can directly optimize the performance of that particular program or that particular functionality in terms of code. Okay, and also this having this knowledge will also help you to optimize and reduce the Java application memory footprint. You will understand how each job object or each class, each method, uh, from every method, every class from the program. So how much, how it is utilized, like, or how it is working. If you want to understand all of them, core Java is required, even to optimize or to understand some memory footprint techniques. If you know that, you will easily understand to identify which object is a problem, a troublemaker. Okay, so, and most importantly, the most importantly, the last point that you have to keep in mind is you have to split the workload of all the Java based applications across several Java processes. You can have single JVM, or you can have multiple JVMs. Okay, this is called vertical and horizontal scaling. They can add one more JVM to the existing server, or they can directly add another server to the existing infrastructure. However, you are not testing on prod environment, you are testing on QA environment, which cannot be a replica or mirror image of the exact prod environment. But you need to make sure that before you see too many issues from the JVM side, you need to make sure that the workload is properly distributed across all the Java processes that we have inside the JVM, and that can happen only with the help of full stack Java developer. Even you don't know how the workload is distributed to all the several Java processes inside the JVM. Okay, but from a load balancer point of view, you can have multiple JVMs with n number of app servers, and you can get some detailed understanding on uh, what best load balancing algorithm that you can use for efficient load distribution. You are not splitting here for the load, right? You know the basic funda of it. If you have server 1, server 2, and server 3, the request comes to the client, then it comes to firewall, then it comes to load balancer, then it comes to web server, app server, and database server, right? That is the use case traversal. But when it comes to load balancer, if you have an entire architecture, for example, let's say that you have some n number of JVMs with n number of app servers. The first JVM or the first app server is handling 1000 requests, the second server is handling 800, the third application server is handling 121. If you don't use the efficient load balancing algorithm, what will happen? The request comes to the load balancer, and now the load balancer has to identify which server is handling less number of requests, and it has to redirect that particular request to the server which is handling less number of requests, right? If you don't use the appropriate algorithm from the load balancer, like FI load balancer or Nginx load balancer, what it will do is, instead of redirecting that particular request to the server which is handling 121 requests, it will direct to the server which is handling high number of requests, some 1000 requests. So at that point of time, there is too much load on that particular server, and the response, it will take a lot of time to give the response. That is how the response times will increase. Now in the same way, you have to use this, you have to split the workload of all the Java based application across several Java processes that we have in different JVMs. If you are working on an entire architecture, if you don't split your workload, it will redirect to some other JVM which is already loaded, and it will create some kind of delay, and it will create a very big impact on the transaction response time. It will make a particular transaction as a heavy weighted transaction. Okay, now let us come back to some kind of basics. If you look at now we'll start talking about the garbage collection. Let's make this session some kind of an interactive session, because I'll get an idea like uh, to what extent you are understanding. Okay, so yeah, tell me what is garbage now. What is garbage in JVM?
Removing unwanted objects, unused memory, unused objects.
Okay, anyone, any other answer you guys have?
Removing the unused objects and freeing the memory for the other objects.
Okay, so basically the basic definition of garbage is collecting useless things, right? So here in heap, unused objects, unreferenced objects, dead objects are called useless objects. So this is an inbuilt function. Garbage collection is an inbuilt function from the automatic memory management inbuilt function of Java inside JVM. So what it does is it will collect all the useless things. The useless things here in JVM are the unused objects. Okay, so the garbage collection is responsible for collecting all the garbage in various areas of heap. Okay, now tell me what is the need or purpose of GC?
If the memory if the memory is not managed by clearing up these unreferenced objects, there will be no memory to create additional objects or to manage the workload.
Okay,
And also, as you explained, Java by default manages the memory, even if the developer doesn't do anything with respect to deallocating the memory. So garbage collection takes care of that, deallocating the memory. So, RK, are you there?
hello.
Yeah, okay, able to hear you now.
And now we are able to hear.
I thought it got disconnected. Okay, let me know if you're not able to hear my voice. Okay, because I disconnected my headset. Okay,
So yeah, the reason for asking all these questions is because you'll be continuously evaluated in any interview. You will be asked with all these questions. Okay, everyone from 1 year to 15 years experience, all the questions will be asked. Now, the need of purpose of GC is, if you remember, I explained you this point in the old languages like C or C++. The programmer is only responsible for creating all the objects, and he will be creating all the objects by using some different keywords that comes with the packages with that compilers and IDEs. So if you want to create an object like student s1 equal to new means that it is creating a new object, right? So he at times from when they are using all the C and C++, they used to use all these keywords to create, delete, update, or do anything on the existing or the newly created objects. And in the same way, the programmer is responsible once is making use of that object, or if the task or if the work for that object is completed, the same programmer is responsible for destroying the objects. He uses this delete keyword. There are some keywords I told you, right? He will use some delete keywords from the packages to delete or destroy all the useless objects. And when he is creating an object, right? Irrespective of any language, the program is creating an object. He will take an extra precautions while creating an object with respect to memory footprint or with respect to the way it is working or the task it has to complete or other dependencies and how it has to reference with other existing objects, how he has to define the roadmap to all the dependencies of the objects, the object node tree, object profiling. So he will keep all these things in mind while creating an object, and he'll create an object very carefully, because if that object is a troublemaker, then all the the complete tree will get damaged with high memory utilizations, with high CPU utilizations, and at times the response, you may not get the complete response of that particular task. So that is why the reason the programmer will completely have some necessary precautions when he creates some object, and the same precautions he will not use when he is destroying the object. Okay, once the programmer is completing that task, or once something is executed by that object, he will neglect that object and he will not delete that object. At times uh, it will soon fill the memory at different areas of heap, and you will start seeing something called out of memory exceptions. This used to happen in most of the languages like C and C++. Because of this neglection, the destruction of objects, because of all these developers' negligence, the entire memory gets filled with useless objects which are of no use. And for creation of new objects, you will not have sufficient memory to get that allocated, right? So in such cases, the applications become completely unresponsive, and there are high chances of going down because of all these memory problems. That is why the reason we came into something called garbage collection mechanism, which came in Java. So after adopting this metaspace from Java 8, and before Java 8, when you have PermGen, uh, the Java people have improved a lot. Like they have improved a lot by avoiding the out of memory exception errors, by avoiding JVM to run out of memory very soon. So they have implemented some practices inside the JVM by incorporating something called metaspace from Java 8. And this is what is happening in Java. The main advantage or the purpose of GC in Java is you have something called automatic memory management. Here in Java, the programmer is responsible for creating any new object, but if the if the work of that particular object is completed, now the programmer has to do what? Basically, he has to destroy, but he need not worry about that. The Java has some inbuilt function. Okay, there is a inbuilt feature called Java garbage collection, which will directly take care of all the unused objects. It will directly come into action for freeing up the memory. This is nothing but automatic memory management. This is created by Sun people, Sun systems, Java Sun systems. This is also called an assistant, which runs in the background, and it is used for destructing the useless objects. And this is called garbage collection, a non-daemon thread which runs in the background. Okay, we'll talk about what is non-daemon thread and daemon thread in thread dump analysis. We'll keep it aside for now. Okay, only just because of this garbage collector, the chances of failing Java applications is very, very less, especially with memory problems. If you take C, if you take Java, if your customer wants to migrate completely from C to Java, most of the people are now migrating from C, C++ to Java. The reason only is because they don't want memory chunk issues. They don't want a memory related out of memory exception issues. So to avoid all of them, they are migrating from C to C, C++ to Java. But again, before migrating, there is a big feasibility study on the application to check the feasibility in all different directions. When they want to migrate from C to Java, you will see n number of performance issues. Okay, it can be only because of the code inefficiencies, and whenever you bring a complete legacy application to Java, you will see too many performance issues. That is only because of the coding, not because of anything else. So the developer has to proactively work, and he has to analyze what is creating a problem, and he has to give the appropriate real-time feedback to the stakeholder. When you see such instance, right, most of the people I have seen, sir, we have an application that is migrated. We have some replication that is moved from C to C++ to Java now, and we are completely moving from legacy to microservices based architecture. So when they see a lot of performance issues, the first requirement that we get is you have to run a performance test. You run the performance test, what will happen? You will see plenty of issues, right? When you see this plenty of abnormalities, can you tell me why they are happening? Why you are getting all those errors? You can say that this transaction is having this response time. This transaction, I have seen a major CPU spike, and it ran out of memory. The disk is not responding. So if you have all these issues, what is your take on that? Anyone? Nothing changed. You already tested the same application when it was in C, C++. The performance numbers are within the acceptable limits. You tested on the new release, and you're still seeing a good performance numbers. Now completely migrated to Java. Now everything changed. But again, you have to remember the code logic, the business logic, everything was, they have some efficient plan, they have implemented the same. They are now getting too many performance issues from real-time users. Now immediate requirement is to test. You ran a performance test, and you're seeing too many issues. What can be the ideal solution? What is your take? Is there on the call?
Yes.
Anyone?
So, sorry, RK, can you please repeat the question one more time?
I have an application. I have already tested that in C, C++. Okay. I have been testing the same application since last 3 years in the name of different releases and hotfixes, and I see good performance numbers within the acceptable limits. Now there is some ad hoc request where the customer wants to change everything from C++ to Java microservices architecture. Now everything has been moved to microservices Java. Okay, nothing has been changed. They have taken all the precautions from the memory footprint, from the designing, from the application side, hardware sizing, everything was fine. Now they are getting too many performance issues and from the real-time users. Now you got an immediate requirement from the customer saying that you need to run a test on the new environment which completely changed into Java. Now you are seeing so many issues, performance issues, high CPU, high memory, and memory leaks, out of memory exceptions. Now tell me, why is that happening? What do you think the main reason for all these activities to happen? Some abnormal activity.
Poor coding standards.
Okay.
In C and C++, deallocating the objects would have been properly managed. But when we convert that code directly into a Java, so there is no guarantee that how the objects are managed.
Right. You're right.
You say the environment change.
That is one main issue. You need to check all the environment, how it is configured. You need to check all the configurations of the environment with all the servers, whether they are appropriate, proper or not.
Yeah.
JVM heap size might not have been considered appropriately for the type of application.
Can be. Any other answers? If this is an interview to all of you, if I am an interviewer, I'm still not convinced with all your answers. Any other answers you guys have? Or can you tell me what 3 main things that I have to check? At least 2.
Mainly the code, the way it is written, that is important aspect in this case, okay, based on what we discussed. If they
That is
have
the
not
first.
written properly, that is one of the important things.
That is the very first point.
Yes.
The very first point is how the code is organized. Okay, you need to have some multiple code reviews on the code before you migrate everything to Java. Okay, and you need to identify all the major changes to work that efficiently. What is the second one?
The JVM configurations, heap size configuration for the type of application, and that I mean, in terms of considering the size of the objects and their nature of memory footprint, based on that, the JVM size should be, heap size should be adjusted.
Right. And I also told you, this is the second point. I also told you, right, the workload across different, the several Java processes has to be appropriate. If you have multiple JVMs, the workload has to be distributed properly across different several processes that we have inside the JVM. That is the third point. The fourth point is you need to check all the configurations, what are all the different servers that you're using, and is every server, the memory, the CPU, everything was up to the expected size or not. You give some hardware sizing, right? Because if you take the memory footprint, it completely varies with C and C++. For C++, it is a different memory footprint, and for Java, it is a different memory footprint. You need to focus on the memory footprint before you code or before you develop something on Java or C++. You need to have this footprint. You need to have everything properly configured. These are all the 4 to 5 main observations that you can give when something is changed from one language to another language. Okay. Now, I told you, right, the thread which is running in the background is called a daemon thread, and this is also called assistant. This garbage collection or collector he acts like an assistant in Java inside JVM, and this garbage collector runs as a background process. All the threads which are running in the background are called daemon thread. Basically, non-daemon threads are user threads. Okay, I'll tell you in detail what is daemon and non-daemon threads in thread dump analysis. Okay, and now I have another question. I found that there are few unused objects, unreferenced objects, unreachable objects, dead objects. they're not being referenced, they're no longer required, no longer used, can I directly delete them? This is a question to all of you. I have so many objects in my heap. I am using JProfiler, JVisual. I found that there are many unused objects. The heap is frequently getting filled. It is not freeing. Garbage collector now is not able to free up the memory. Now, not you, even if it is a developer, can he directly delete an object which is no longer required?
Yes, of course. If he is confident, he can delete.
Can you tell me why?
He'll check if I'm a developer, I'll check that whether it is referencing to some other projects or if it's useful. And if I'm confident that it's not useful, then I can go and delete that, right?
No, you cannot delete any object from the JVM.
Yes. At
The
runtime,
reason
we
is,
won't be able to delete. Yes.
reason is because if you take the object node graph, right, you will have plenty and plenty of dependencies on that particular object. If you are killing or if you are directly removing that object, that functionality will not work. You can see not found or I mean page not found, some kind of errors you see, right? If you are killing the main reference, all the other existing dependencies which are referenced to that particular object will not work. So in Java JVM, we cannot delete. It is, I mean, it can be a performance engineer or even if it is a full stack Java developer, he cannot delete any object from the JVM. Okay, but he can make that object, that useless object, which is no longer referenced, which is no longer used. I mean, if he thinks if it is not required or if the task of that particular object is completed, now what he can do is he can make that object eligible to be garbage collected. You can make such objects to be eligible for the garbage collection. There are 4 different ways. Okay, this is the most important interview question that I ask everyone who's tell me that I have some experience in GC tuning or I know I worked on GC logs analysis. So even though the programmer is not responsible for destroying all the useless objects, but the programmer is responsible and he can make any object to be eligible for GC. Okay, but before that, being a programmer, he has to understand if the object is required or no longer required. He has to understand that. Even that is the important point. Even if you have some experience in Java, you need to think about that object twice or thrice. Will that object will be used for future references or will that object be called sometime later? You have to think all of those scenarios and accordingly you need to make that object eligible to be garbage collected, right? So if this question is asked to you, you need not get panic, but you can, it is not your job, it is a full stack developer's job and he is the only responsible person to make all the objects, the useless objects eligible for GC if it is no longer required. Now, do you have any idea like how can we make the object eligible for GC?
Okay, one question. See, if I'm saying that it is an unreferenced, unused object, right? So why can't I go and delete that object? Because anyway, we are telling that it's unused.
No. See, in the object node graph, even if this object is not referenced, some other object is referring to this object. There in the, if you look at the object node graph, it will have too many references, too many connections to the existing node. So if you are deleting that particular object, the other depending object will not be able to do that particular functionality. It will not complete that task and it will result you some error.
So in that case, it's not an unused object, right? It's a reference object only.
No, it is not like that. Referenced object is like, when I say this referenced object, this is being, it has to refer something, right? But you are not worried about this object is referred by other object or not. If this object is referring to someone else, you consider that case. If that object don't have any references, and if it is still idle for 2 or 3 days, it will be automatically garbage collected in the minor GC. Okay, you cannot, it is a simple straightforward answer. You cannot, even the full stack developer cannot delete any object from the object node graph. If you are deleting any object, that will create a mess in the complete object node graph, and that functionality will fail. Okay, if you want to understand more about this, you can go to how to doingjava.com to completely check the object node graph. Again, that is not our scope in PE class to explain. So if you want, I can help you with the link. You can go through that link. Again, for that you need to have the Java experience to understand the complete picture in detail. Okay, so now how can we make an object eligible for GC? How can we say that object is eligible? For example, if you have 2 objects, how can you say that one object is eligible for GC? Just now I told, right?
Same answer is same. It should be a unused object, unreferenced object.
Simple. When a specific object has no reference, then automatically it is eligible for GC. That is the first point. And any other point? If the work of that object is completed, then the object is no longer required. Then it is eligible for GC. Any other point? If the object does not have any reference variable, then the object is eligible for garbage collection. How many of you know what is reference variable here?
Sorry, can you come again?
If the object does not have any reference variable, then that object is eligible for garbage collection.
After that, you said something.
Sorry?
After that, you said something.
No, I am saying that I'm explaining you the reasons when the object can be eligible for GC. The last point is, if the object does not have any reference variable, then object is eligible for garbage collection.
Okay.
So there are 4 main methods. Okay. 1 minute, please. Before we talk about the GC algorithms today, you can go here, and I have written this article only from a performance testing point of view. Okay. If you read all the different blogs, it would be very difficult for you to understand, but I have written this at a very high level. Okay. You will easily understand. So basically, the live object is called reachable object. This is referenced by someone else. Okay. That dead object is also called unreachable object, unused object, which is not referenced from anywhere. Okay. So here I have clearly written the purpose of garbage collection. Why garbage collection is responsible for. You will have some memory allocations like this. Okay. So if the memory is occupied like this, there will be something like compaction. Compaction is nothing but It will identify all the reachable objects. I'll tell you what compaction is. I did not explain you that, but what I'm telling you here is, if you look at the diagram, this is how the allocation happens. After allocation happens, it will freeze the objects. Unused objects will be removed here. And in the compaction, if you look at the gaps right in the memory, like you have, if you take this entire block, you have reachable objects randomly in the entire area. You have one block here, and one block here. And you have some free memory here, and the third one is after some allocation. The compaction, what it will do is, it will identify all the reachable objects, and it will align everything in order. All the allocated part will be allocated here. In the last, the free memory will be available in the grid. So if you're having some high response time, or some kind of if you experience too much of slowness in any kind of Java application, majority of the reasons are because of compaction. The time spent in compaction is very, very high. Compaction is nothing but identifying all the reachable objects, putting all the occupied memory, the random different grids into one place, and the free memory next to the block is nothing but compaction. It will take a very long time to align everything in order, the used memory and the free memory, to set that in order. This compaction will happen. This compaction will happen, and it will take a very longer time than usual. That is why the reason you will see major slowness or high response times only because of the compaction. And the time spent in compaction will be very, very less in something called G1GC collector, G1C collector. It is nothing but garbage first collector. Okay, this is the reason why I explained you randomly this part, is because you will get a question, interview question, that why everyone is nowadays using G1C collector. We have algorithms, right? We have 4 to 5 algorithms in garbage collection. If you go down, this is the heap structure. This is how, before marking how they are allocated, then this is how it will fill the hidden space. It will copy the reference objects. This is how the object aging will happen. And see, these are all the different GC algorithms. From a performance standpoint of view, I have written very clearly when to use what and the use cases. This is the throughput collector. This is the use case. This is the CMS, and this is the use case. And the collector that I'm talking about is G1C. This is the garbage collector that is being used by many of the organizations and most of the Java-based applications. Earlier, they used to use concurrent CMS. This is called CMS collector, concurrent mark and sweep collector. Just till last 1.5 year, before 1.5 year, 2 years, I have used this CMS collector as a garbage collection algorithm. And from the last 1 year, I have been using something called G1C. So I have also clearly written which algorithm that you need to choose. Is it serial, or is it CMS, or is it parallel, or G1C? It is always G1C. You can directly, the straightforward answer is you are using G1C. If someone is asking you why, the time spent on compaction is very, very less. Okay, basically, if you use other collectors, what will happen is, it will first check for minor GC, it will check Eden, then minor GC will happen, it will check survivor space S0, then it checks S1. Whatever the objects that are survived, they are promoted to older generation. On the older generation, you will have something called major GC that will happen. So here, some list of minor GC cycles will happen. Basically, if you look at this minor, right? Sorry, let me show you this diagram to avoid the confusion. If you look at the hotspot heap structure, this is the place on the younger generation, the minor GC will happen. It checks the Eden first. It will remove the unused objects. Then it will check the S0. It removes the unused. Then it checks the S1. Then it removes the unused. In the tenure, the major GC will happen. In major GC, some number of minor GC cycles will happen. If when the object is getting promoted from younger generation to older generation, the object has to survive a minimum number of minor GC cycles to get that promoted to perm gen. Okay, so you can set that threshold in the tenured in the older generation. You can set that threshold. So you can give that 8 cycles or 9 cycles, or you can give up to 15 cycles. Basically, the threshold value is 12 to 15 for tenured. If the object is surviving, once the object is promoted to younger generation after completing the minor GC, once the object is promoted from younger to older generation, now the object in older generation has to survive the number of cycles that you have set, the number of minor GC cycles that you have set, and it has to survive all the cycles. Then only this object gets promoted to permanent. Okay. The reason why I explained you all this, because if you take G1C, it will not go to Eden first. It will not check S0, or it will not go S1, or it will not go tenured or permanent. Whichever memory area is getting occupied, it will identify first and it will garbage collect. That is why it is called garbage first collector. It does not have any process like it has to go to Eden first, then it has to go to S0, S1, then it has to move to older one, then it has to, after surviving some 15 or 10 minor GC cycles, then it goes to permanent. It is not that. When you are using G1C garbage collector cycle, it means that it will automatically identify, it will scan the complete heap first, and it will identify which area of the memory is getting occupied fast. It will identify that, and it will execute, it will garbage collect all of them, and it will free up the memory. This is a very efficient use case, a very efficient garbage collector that every developer or every performance engineer is recommending or asking to use this use case. Okay. Anyway, we will talk about all these benefits, merits, and demerits of these algorithms tomorrow, and I'll take you the ways to heap them. But before that, I told you, right? No object can be deleted by any of the developer or a performance engineer, but however, we can make that an object to be eligible for GC. Okay, we have 4 ways. If you go in depth, again, you need to read a lot. You need to understand. You need to, in parallel, you need to learn Java to understand all these concepts. But do not break your head. But this will help you for your engineering, performance engineering learning practice. That's all. Nothing else. Again, if you want to understand all these different algorithms working, or how you have to write efficient, how you need to build some efficient program using all these different techniques, for that Java is mandatory. Okay, got it? So I'll explain you few different ways to make an object to be eligible for GC. If I write like this is the first way I'm explaining. If I write like this, can someone tell me what did I write here?
You are creating two objects of class student, S1 and S2.
What is a class here?
Student is a class name.
What is S1?
S1 is an object.
Excellent. What is new here? What is new?
New is a keyword to allocate the memory instantiation.
And I'm creating an instance here, right?
Yeah.
So student is a class, S1 is an object, new is a keyword, and the new student is the instance that I'm creating. This is a very basic, okay? So if I feel that student is not required, if I felt like the work of that particular object is completed, now I'm giving S1 equal to null. What does it mean?
We are nullifying it. That means that S1 doesn't it is not being referenced, and it loses
When
the
S1,
memory is
excellent. When you write some for any object, if you write some object 1 equal to null or student 1 equal to null or O2 equal to null, it means that it is not pointing to any object. Then automatically this object will not have any reference variables, and this object is eligible for GC. This is called nullifying the reference variables. Got it? If the programmer thinks that any of the object in the program is not required or no longer used, then he will set that object to null. If you write student S1 equal to new student and student S2 equal to new student, these are two different objects. When I write like that, none of the object among those two are eligible for GC. But when I write S1 equal to null, it will not point to any of the object, and this object will not have any other reference variables. Setting S1 equal to null is like breaking all the references to that particular object and making that object to be eligible for garbage collection. Okay, and the best coding practice from the Java developers is like if an object is no longer required, it is highly recommended to make that object eligible for GC. This is how they reduce the type of memory leaks that we get in our load test. They mark many of the objects which are low priority. Yesterday I explained a few references, right? Weak reference, soft reference, Phantom reference. Depending upon the reference, if they want to change any of the references to any of the objects, if they feel that this is not required, they go to that particular code or program and they'll mark many of the objects to null. Okay, so assigning null to all its reference variables, we are making automatically to be garbage collected by default. This approach is called nullifying reference variables. This is one performance optimization for garbage collection. Got it? The objects are heavily created. Too many memory leaks you have. The object is a problem maker, and garbage collector is not able to delete that particular object, remove that object. What do you do that? You use a profiling tool. You identify that object. You ask your developer to mark that object as null. Instead, you will ask them to create a new object. You will ask them to write it efficiently, and you need to get that connected to other reference variables or other existing dependent objects that we have in the object node graph. But this is a very good code implementation practice from a development side. In coding, you can also see if you look at some of the programs, if you have access or if you're writing some CI/CD pipeline or if you have experience writing some Java codes, if I'm writing something called con equal to null, what does it mean? What do you know? What is con? What is con here?
That
Con
is
is
an
nothing but, yeah, this is connection object. Okay. What I'm doing here is I am making this connection object to no longer required state. It means that the connection object, I'm deciding if the connection object is required or not. So what I'm doing here is, once the DB is already connected, then why do I still maintain this connection object in the memory? I don't do that, right? Connection establishment will happen only for once. Once it is connected to the DB, and once this object is task is completed, I don't want this connection object in my memory. So what I'll do is I'll set connection is equal to null. It means that I am nullifying this reference variable of this object. Okay, so this is one way. The second way is called reassigning the reference variables. Okay, the same way you will have student S1 equal to new student, student S2 equal to new student. What do you mean by reassigning here? Now both the objects are not eligible for GC. If I want to make one of the object to be eligible for GC, what should I do now?
You can say student S2 equal to S1.
Now what will happen to S1?
S1 will remain and S2 is free.
Right. So what you're doing is you can, for a better understanding, I will use a word called reusing, but it is not the appropriate word. It is always reassigning the reference variable. You are directly calling S1 to S2 and you are making S1 or S2 empty. Here now the S1 object, now the S2 object will be empty and it will be garbage collected. There is no student S2 equal to new student. As you are directly giving S2 equal to S1, this is nothing but reassigning the reference variables. After some time, when you give after giving S2 equal to S1, after some time S1 will be no longer required, but I have to create a new student again. Okay, again I have to create a new object and work this object S1 is already completed, so I'm using the same reference variable of this new student object to S2. Got it? So it is like you are using one object reference variable to the other existing object, and you are freeing up the first or second object depending upon your use case. Okay, in that way what you can do is you can minimize the number of objects that you want to create, and this will help you to improve the performance. Okay, this is called reassigning the reference variables. And again, if you want to understand all these concepts in depth, you can start it from today. You can start installing your Eclipse IDE. Go there, write a basic Java hello program. Java basics will not take 30 minutes of your time. Go through the Java basics. It will tell you what is class, what is method, what is array, what is a variable, what is an instance. Learn all of these things. Then write a simple Java hello program. Hello world. Start with hello world program. Then adding two numbers, subtracting two numbers, then multiplication, then slowly write Fibonacci series. Then you will understand all these things very easily. Creating an object, creating a class, creating a method, everything. Now the third way is you need to create objects inside a method. Okay. For example, not write. This is not an idea. So here I'm creating a class. Oh, sorry. Creating a class called test. Static void main. Okay. Now what I'm doing is if I create a method here, I have to write this program and show it to you. Tomorrow, if I get some time today, I'll show you this program. Okay, I have one program with me. So what I'm trying to tell you here is whatever the objects that you are creating here, right? You have to create all that objects inside the method. What happens when you create objects inside a method?
They become local variable to that method.
This program. So once the method objects created inside a method is the third way for making the objects to be eligible for GC. But so when a method is executed, right, you write a method. In that method, it will have some reference variable, sorry, some local variables. And when the method is executed, after completing the method one, both the objects that I have for this method one, which are written inside a method, they are eligible for GC. If you have some 4 to 5 objects, you need to write all of them inside a method, not outside a method. If you are writing outside the method, they are not eligible for GC. If you have one method, for that method, if you are writing all the objects inside the method, by default, whatever the objects that you have written inside the method are eligible for GC. Okay? When S1 and S2 are created here, if you look at this program, this S1 and S2 are local variables for method 1. Okay, so whenever we call this method, these local variables are created. Once the method completes, the local variables will be destroyed. That means that the objects which are created inside a method are by default eligible for GC, and once this method executed, these two objects will not have any references. Okay, no performance engineer will have this knowledge, but if a performance engineer who is taking your interview is a full stack developer for 1 year by any chance, he will ask you all these questions. Okay, I have 2 years of developer experience. If I get a profile, if they are asking me objects created inside they say me that objects created inside a method, I'll ask that what is the reason you are writing inside both the objects inside a method? Why are you not writing outside a method? And what are the objects that I have created S1 and S2? What S1 and S2 are created here? How are they related to M1? I can say that this S1 and S2 are local variables of M1. So what happens when I execute my M1? When I execute my M1, the method, the completes the execution, the local variables will be destroyed. What are the local variables here? S1 and S2. The objects which are created inside a method are by default eligible for GC now. The reason is because these two objects, when the local variables are destroyed, when the method is executed, these two objects will not have any other reference now. Okay. The one last way is called island of isolation. Island of isolation is like basically it is deciding a group of objects, like even a single, if you identify a single unreferenced object is called island of isolation. Island of isolation is nothing but you look at your heap, you have so many unreferenced objects. All the unreferenced objects which are collected by garbage collection, they're removed. That is fine. There are few unreferenced objects which are not removed by garbage collector now. So you have to take some action on it by creating some 4 ways to make that objects to be eligible for GC, or you can directly make them. But here, when I call it as an island of isolation, every single object, unreferenced object, is an island of isolation. That means that whenever you see some unreferenced object, you directly take action on that, and you make eligible all these unreferenced objects. You reassign them, or you nullify them, or you take that objects and you put inside a method. That is how you do it. And you finally, your target is to remove all the unreferenced objects. This is nothing but island of isolation. Island of isolation in Java is a complete take from a Java developer. So this is all about garbage collection now. Tomorrow we'll talk about the garbage collection algorithms and how to analyze GC logs. We'll close GC. And from day after tomorrow, we'll talk about red dump analysis. Okay. And after that, I'll show you the different ways of taking a heap dump and thread dump. How do you analyze that? And after completing this course, I'll give you some list of close to 90 to 100 questions. That is what is my plan. If you are able to prepare all these 100 questions from a performance engineering standpoint, if you are really able to explain the exact scenario of that question, you can crack any interview. Any product based interview, even if it is having 9 to 10 rounds for a senior performance engineer role. But only thing that if you want to crack all those interviews like McAfee or Visa, MasterCard, PayPal, ePay, LinkedIn, if you want to crack these interviews, Java experience is a must. If you don't have Java experience, if you don't understand Java, if you cannot write any simple program, even if you are a guru in performance testing, load runner expert, neoload expert, JMeter expert, correlation expert, it is of zero use, honestly speaking. So that is why the reason I repeat the same point in every class. You guys need to have Java experience. You can learn Python, that is not a big deal. But if you know Java, it will help you in multiple ways. You can become an SDET for those people who are working in USA. If you learn Java, the main look at any of the bench sales or any recruiter, if you take half of the requirements are SDET, they are expecting an engineer to have automation testing and performance testing. You got nothing to do with Selenium tool. If you want to build a framework, you need Java. If you want to tune JVM, you need Java. If you want to know the heap, thread dump code, hardcore activities of that, you need. If you want to do the code optimization techniques, code redundancy, code optimization process, if you want to take part in code review process, you need to have complete experience in Java. You can learn Python, not a big deal, but you're not going for a job, you're not switching as a Python developer. Python is used everywhere. Selenium, Python, Selenium using Python, machine learning, data science, everywhere you have Python, orchestration, DevOps, everywhere Python is required. Python is not really required if you want to go for performance engineering. If you learn Java, learning Python is very, very simple. It's a straightforward language. So enroll for Java. You can complete this core Java in 30 days of time. Get some strong resume with some development experience so that the resume gets shortlisted for all ServiceNow. For people who are working in Hyderabad, ServiceNow will call you. Salesforce, McAfee, and Amazon, all these people will call you only if you mention in your resume saying that I have 1 year of development experience. Got it? And even if you go for an interview, it is not like a full stack Java developer. They will ask you simple logics. That's all, nothing more than that. All right, it is 8:30. Sorry for taking long time today. All right. Thanks all of you for joining and thanks for your time. Tomorrow we'll complete GC, and from day after tomorrow we'll talk about thread dump analysis, and again all the questions will be discussed when I show it to you in the real time. Okay, try installing the files that I have shared. YourKit profiler, or I did not share YourKit profiler. You install YourKit and you can install JProfiler. I would say install JProfiler, install Java on your local host, and you can directly connect the localhost JVM instance that is running to your JProfiler and see all the different activities.
Okay, I didn't get that YourKit profiler in the recent link.
No, YourKit profiler. I showed you, right? This is the sorry. These three I shared actually. This is JProfiler, this is YourKit Java profiler, and MobaXtern. This is for connecting for Linux machines. This is a licensed version. I am sharing you the cracked version. Okay, do not use it for any of your official assignments. Don't do that.
No, this email I didn't receive. Okay, I will ping you.
No, I shared it with Anita madam. Anita madam will share the drive link to with all of you. Okay.
Okay.
Because I don't have all the email IDs, so it is becoming hard for me to send all these files to everyone. So every hour I'm getting a message saying that, sir, this is my email ID, please share it.
Okay.
So I shared it with Anita madam. You can contact Anita madam to get all of these files. Okay.
Hey, RK,
Yes,
can
sir.
you send the name of the person you say you're gonna recommend for Java, please?
Let me stop my recording. One moment. I have